All right, let's basically go over the nose assemblies first on both of these tools. And this nose assembly is basically going to be the same on your half m4v. You got a sleeve and 2 half nuts. And that pulls off. Here's the sleeve, which goes over the 2 half nuts. Locks the assembly together.
Great.
Now here's the part that we've already talked about. When these nose assemblies get installed on the tools, the tool needs to be either recently hooked up to a unit or hooked up to a unit and powered up. On a 940, you want to actually hook the unit up, trigger the tool to get some hydraulic pressure in so the piston returns all the way. When the tool is taken down and especially serviced, you don't know where the piston's going to end up. These will drift back on their own. There's another small clip in the back. Beautiful. Yeah, it came out. We've got a 2-piece follower assembly on this. It's got a combination of springs and O-rings, which will be on the data sheet for this particular nose assembly. When you're putting this back together, it's helpful to have that data sheet in front of you, because we have a lot of different combinations here. It might not necessarily be a spring, it could be all O-rings. We've gone back and forth on that. But you want the right amount of O-rings on here. When you get this back together, you want to make sure the jaws are snug in the nose piece. That's the whole deal. If they're slopping around, when the pin gets pushed in, we can get one of these slid back and out of phase if they're not tight. And that's the reason for having them tight up in there. If you're getting a lot of jaw breakage, issues like that, check the nose assembly. The other issue is cleaning this thing out. If it can be cleaned out on a weekly basis, would be the best thing you can do to ensure that it's going to go. It's actually going to push the tool further and obviously push the jaws further. What happens is you actually get enough buildup on the top of this and on the inside of the anvil holder, or the anvil in this case, that it won't allow this to shove all the way back. So you actually won't get it to push off either, if it gets bad enough. This one doesn't look all that bad, but there is some crud buildup in the back of that. Check this, make sure that the ejector's tight. This actually screws onto here, so it's 2 pieces, right. And this is kind of a technique to get these things in here. It's probably the most difficult thing about this whole assembly is getting these jaws back in here. But
lay them in here and then use the pusher to push
them all the way up.
Okay.
Beautiful, beautiful.
It's the experience.
He's had his finger modified.
Yeah.
All right, and then you want to make sure that you got all the O-rings that are still left on here, and you guys got quite a combination. I'm not sure if this is exactly what we're looking for. I'm going to guess they should have all been this size. Somebody stacked up a bunch of small ones on here. I don't think those are the correct O-rings. We'll put 5 fresh ones back on here.
Kind of hold that brackets here.
Got a washer spring assembly. And the top of the follower. Beautiful, beautiful. There's a data sheet. We are calling for 5 O-rings. Make sure the jaws are still in the right orientation. Clip back in and make sure the clip...
Just hold that right there again and just turn it toward the light a little. Oh, that's good right there.
Clip back in all the way.
Super.
There's also another little trick. Go ahead, let's pull it. I'll pull this trick back, clip back out. On all these clips, they're stamped. So you're going to have a sharp edge and a round edge. If you put the sharp edge up, it'll grip a lot better. You're not going to be able to see that, unless you got magnifying. Feel the jaws coming all the way back up, and you can't hear them rattling around in here. If they're rattling like a maraca in here, no good. Now at this point, this is where we put the tool back in to make sure the piston's all the way returned. And can we plug that in? As you can see, that thing did drift back, and then we're out a little bit further than we were before. So you got to keep it, you know, it's got to be, you should have a unit in the shop to really set these noses to make sure that you're all the way out. This is the flat that we're looking at to line up with the edge of the tool. Once that disappears, we're correctly aligned.
When you line up that notch,
this notch
has to be level to that.
Should be level to the end of the nose.
One more turn.
So we got one more turn to go, and my piston is giving me fits. So the next step is the brass ball has to go in one of the grooves. There's 4 grooves around the piston to lock it. So you got to feel that go in the groove. Once you feel it go in the groove, put the lock ring down.
But ideally, you have to line up that mark to the...
Ideally, you want that mark to be level with that. So it's just appeared, or just so you can see it. We're real close, like probably half a turn away. And we're still going to get, we know we've got good, I got tension against here. If this thing just fell in with no tension on it, then we know we're definitely way too far back, or the piston slid back. Slide the lip ring on, and we're locked. Put your clip back on. And that tool would be ready to go as far as the nose assembly goes.
The most problem we have on this plant
problem. Most of the time what your issue is going to be is you're going to find a worn anvil. And in this section it'll actually push up a ring. This one's worn, but it's not bad. It's probably still giving you a full swage. When this goes, it's going to start putting real big grooves in the collars. You can see it. And it'll swage less and less and less, and that's what I mean by it's pulling too quick. Tool just pulls. It doesn't know anything. The pin's actually got the tension set in it by that brake neck.
See it.
So this tool is going to break at the same pressure every time. The pin really tells it when it's going to break, not the tool. The tool just pulls. But if this anvil, this area right here, the swaging cavity, if that's worn, it's going to cause too much friction and it's not going to swage it all the way. So it's going to be in this area right here that you got to look. And there'll be a ring pushed up in it. So you can go down the line and basically pick out, without even seeing the tool, which one's the bad anvil. And really that's the best way to go and look. Look on that line occasionally. Make sure that they're getting full swages. They're getting half swages, find the tool, it's probably the anvil that's gone. And nobody complains until it's really, you don't want to see less than a 3/4 swage to have a good huck. Any other questions on that particular nose assembly? It's fairly straightforward. So the most important thing is we want that piston out. We're going to have problems with ejection. If it's too far out, then you're actually going to be deadheading it right back into here as far as pressure goes. And if it's way too far out, you could be snapping threads off. Do you have any of the special, like the piston bullet or the seal ring to put anything back in? Do you have any special tools for these?
Especially we've got it as a spanner right in the back side.
All right. There's one, usually one lock bolt back here that holds the ring in. Yeah, it's usually a socket head. Somebody's got a button head in here, but whatever holds it. I prefer the socket heads over the button head just because you can get a little larger hex wrench in there. New tools, generally those will spin out on their own, but after they've been hammered up around the back end, they're going to require some force. There's another little locking disc right there. Which may fall out, or you might have to dig out. Looks like somebody's done some work in this thing. That's exactly what we're looking for. Brass drift. You gonna catch her for the piston? Go ahead and pull the. Before you get too far, you always want to inspect your cylinders for any scores. We polluting all the. Yeah, we're doing a good job. Now. If you get a little file, it helps if you've got any.
Needle file or bigger?
Bigger. If you've got any dents on this surface, so we're going to push this thing back through. This one isn't bad, it'll probably go through, but I just want to make sure, because once you get halfway, then you're going to gouge it all the way through. Well, just you may not get the gun as good as it was. Like I said, this one's not in bad shape at all. Basically, we got 3 sets of backup rings. It's a nylon ring and O-rings. These backup rings are a split ring design, and this is a good example. This ring was not sized properly. I don't know if this is going to show up.
Yeah, you can see that pretty good here.
But that bump in there should not be in there. There should be an even slit across here, and it'll come down even. This worked because you were able to get this back in without bunching this thing up and cutting this. When the backup rings come from Huck, you actually have to take a razor blade and cross cut these to get the right size. They're not sized from us, so you can't just throw them in there, otherwise you'll get this, which worked in this case. And I'm not even going to fix this because this has already been formed in there, and it's not going anywhere. And it wasn't leaking, so we knew that was good. You want the manual in front of you when you do this so you get this on right, but if you can remember, the backup ring always goes in back of the pressure. So in other words, it's going to be the O-ring first to the pressure, and then the backup ring. And what that does is it's sized so closely to the surface, it doesn't allow this O-ring to extrude back out of here. If you were to put this in backwards, that's what would happen. Eventually the O-ring's just going to push its way right out of there. Piston, you're going to look at both surfaces. Piston rod this way. For any deep gouges, Generally, if your fingernail stops in it, it's too deep. If you can't get it out with a piece of emery cloth, you got to scrap the piston. And that pretty much goes for both sides. This piston's in pretty good shape. Then you want to look for any gouges here. That would tell you probably got gouges there. Inspect the cylinder for the same thing, which is a little harder because you got to get some light in there and get the oil out of it. The cylinder looks nice and smooth, so we're in good shape there. Actually, the cylinder is in great shape. So, had we had new O-rings and backup rings, we're going to put those on. And you'd be ready to put the tool back together. Now, for assembly purposes, we're pretty oiled up here, but if you've got a light grease, assembly grease, everything should be lubed up before you put it back in.
Should you clean those threads up first?
Probably wouldn't be a bad idea. That's our killer right there. It looks like somebody has not gotten the ball in one of these grooves, and the ball has ended up smashing the thread there.
Oh, yeah,
And these are the grooves I was talking about before as far as the nose assembly's got to catch in one of these grooves, that ball. So, that point right there, have you got a chaser or a real small file to get in there? We got the set right here.
Is it always necessary to change the backup ring if it's a good ring?
The backup ring you can actually reuse if it's still...
I never change them in any tool repairs that I do usually. The O-rings usually.
Sometimes you're going to get a lot of cases where the O-ring has blown out and it's taken the backup ring with it. If the backup
Well, if that's okay. If the backup ring looks good, I always think.
Right. If the backup ring's distorted at all, it should be replaced.
Yeah.
This tool, this one requires really no special tools because of the way it's designed. Everything's fairly easy to get in and out. The other one, the other two you've got, you should probably get the piston bullet for it. That screws on the top of the piston, and that'll allow you to push it through and slip over the seals rather than catching the threads on the way in. Be stingy with the grease. Start by putting the front of the tool back in. Get stuck on the way in, don't drive it with a hammer, because that's gonna put some dents in your cylinder that you don't want. Now you can stack this whole assembly up at once if you prefer. In other words, you can put your piston in there, and we do have. Didn't show you those. We do have the internal O-ring and backup ring inside of this assembly also. That actually seals the front half of it. Again, that's going to go in a little bit tougher with new seals in there. As long as you know you're fairly square, you can do a little bit of tapping on the end of it. Just be very gentle. It should pop in there. Now the important part, the dump valve. there's flats ground on the dump valve, and what this does is when it pulls all the way back, so it doesn't deadhead to the back of this, it's a little safety feature in the cylinder. It's actually the hydraulic fluid goes through here, so you can't develop full pressure and deadhead the front of this thing. So you want to make sure that the flats are to the back of the tool. If you put it in the other direction, it's going to start dumping right away, and you're not going to get anywhere. It'll just bypass. You want to make sure when we put this in here that this is snug. It shouldn't be slopping around. Otherwise you're going to get bypassed there again.
Let's see if I can see that. Oh yeah. So once it goes, the oil passes through that flat.
Exactly. So as this piston comes back, it's normally forward through the stroke. It's going to come back. When it gets to the back of its stroke, it opens up the flats, releases the pressure. You still got a little bit of pressure generated, but you're not going to get the full pressure and just sit there and deadhead, right? So you're not blowing things out of the back end of this. Persuasion, pop the front end out. Again, flats the back. There's the O-ring, the internal O-rings. Same thing with the backup ring. These are going to give you more fits as far as sizing goes. Again, with the new O-rings on there, it's going to go in a little bit stiffer, but it should pop in fairly easy for you. Little disc, drop that guy back in there. Not a lot to these tools. Basically, it's a hydraulic cylinder. Now you want to snug this down until you can feel it, and then you back it off to the nearest hole, which in our case happens to be quite handy. And sometimes, I mean, you might, the hole might be back here, so don't be afraid to drop the bullet. It doesn't have to be dead tight. There's a little bit of room for that to go back and forth. Size wrench, or at least a crescent wrench on this stuff, is you can keep the channel locks away from these tools. Generally these are tight enough, so the right size wrench is preferable to get them off. Once again, you guys are doing a good job. Sometimes the extension, this is actually an adapter, will come off with your nose assembly. There's also a hex in the back of this if you have to break that loose. But you guys get this on here good and tight. This is pretty simple. Unitized jaws, collet. Again, you want to make sure that everything's clean.
The right jaws.
The right jaws. This looks pretty good as far as cleanliness. And the right data sheet in front of you, confirmed right data sheet, then you can check it against to make sure you got all the right parts. Unitized jaws are real simple. They go in, that's it.
Did you put them in and over in the light here?
Sure.
Oh, hold it. Okay.
Just slides in. And everything's nice and clean. There really is no adjustment on this tool as far as you don't have to worry about it. Everything gets just cranked down tight. Which you guys definitely do. If you have an issue with them loosening up, you can even use blue Loctite on those threads. It makes getting it off kind of a pain, but again, if this loosens up, what happens is this piston actually grows in length now. Now we're deadheading this collet against this anvil, and you're losing stroke every time you do that. If this backs off enough, that'll break the collet because now we don't have enough threads engaged. You can see there's a little bit of crud buildup in the bottom of this. Wow, that's a beautiful shape. This should actually this should be replaced.
Actually, what happens?
Doesn't work out that way, but yeah, that should be replaced. And that just slips back on. Now again, if you put power to the tool and you've got all kinds of space in here, you know something's not right. And I'm not going to put that on real tight. Alright, this is the 940 power rig. This is an older unit. We no longer use this type of return pressure switch. You probably got newer ones out there. Not a lot of difference. The adjusting screw comes out this way rather than this little screw back here. The boxes are a little bit different as far as different components. It does all the same thing, it's just different brands of relays and brought up to date. So there's really no, between the two of them, you can figure them out.
Same brushes.
Same brushes. Brushes have not changed between this basic pump unit, besides for the electrical box, and some of the components like the pressure switch haven't changed since it's been out. This unit basically is going to be kind of, there isn't a lot to work on this thing other than setting the pressures, checking these brushes, which we're going to go ahead and I'll go ahead and pull one out for you, and changing the fluid is the main things to keep this pump running. The pump is replaceable as a unit. There's nothing to work on it. Basically, you pull these screws out, pull the whole motor off, unbolt the pump, put a new pump on. So there's nothing to work on there. It's a swap and replace. These things tend to go for a long, long time. And the biggest killer is contamination in the oil, because you'll get actually from the tools, every time you pull a rivet, as you know, as we talked about cleaning out the nose assemblies, If that gets dirty enough, that pushes beyond the seals and actually gets into the oil, and you'll see it in the bottom of these tanks. You'll get sediments of shavings, and that's where they're coming from, right through the tools. So if you can keep these changed, I would say 6 months to a year if you could change out the oil. And by changing out the oil, go ahead and pull all these screws out and pull this right out. There's a screen on the bottom of the pump. Clean that off and clean all the debris on the bottom, because if you just drain this, you're going to have crud on the bottom of this pan. Other than that, as far as maintenance goes, the brushes are what we want to look at. And I do not want to be plugged in for this. It's a real simple plug setup. Plastic plug. Brush comes on just like a normal brush. I'm saying if you got, you know, a 1/4 inch left in that brush, it's time to be replacing it. If this brush wears all the way down and we're pushing to the spring, then we're going to screw up the armature. The armature is replaceable. You can buy that as a unit, but it ain't cheap. This thing will run forever, basically, if you can keep on top of it. Real simple. It just goes back in there. You can see that it's, you know, it's keyed, so it's only going to go in one way. And then turn the cap back in, and with a screwdriver, just, you don't have to over tighten it, just snug it up. And that's basically the motor maintenance. The other replaceable parts on this thing, as far as electrical, you can get the relays from us, motor starter, and so forth. The relay may burn out on you. You know, it's real easy to track down if it ain't clicking. On this thing, start with the easy stuff first. Make sure that the tool is actually, and have you got this shorted out, or, okay. Generally we have a remote trigger that you can test this with. But a lot of times the wires pull out of the trigger in the tool, and that's 99% of the time why this unit doesn't work.
That's why we have that.
You stick this in there, and if it works,
it's either going to be the tool or the extension cable.
Right. Hydraulically, if for some reason this unit isn't working and it's actually the motor's turning, but you're getting no pressure. If you're getting pressure on one side or the other, that means if you're getting pressure on return but not on pull, or vice versa, the pump is still good. Then you want to look in the directional valve, the 4-way directional valve here. Now we do sell a seal kit for this, but it's just O-rings and backup rings. The only thing that's going to do for you is if it's leaking. That really doesn't have anything to do with the function. They're 2 poppet valves that slide back and forth. And if the poppet valves are worn or leaking, then that can cause pressure loss on one side or the other. You can either replace this whole block, or I think you can send these in to a service center and have them rebuilt, which may be cheaper. Again, that's a total swap out, so I mean there's nothing really there. You just take it off, put the new one on. Same goes for the solenoid on top. Any questions on as far as how this thing functions?
What's the maximum pressure you can put on these things? What's the maximum pressure you can adjust these things?
We always say 10,000 pounds. They're actually rated to 9.8 or something like that, close to 10,000 pounds. You're not going to, with any of the equipment you're running, you're not going to need to get near that pressure.
I know with the newer half-inch nuts, we have to bump up the pressure on the power.
Yes, you have the 2600 series? because the piston is smaller, you have to pump up the pressure to get the same results pulling pressure. These pistons are larger on these tools, but they're heavier. So with a smaller piston, lighter tool, but you need more pressure at the hydraulic rig to get the same work done. And that's the difference. Now, if you pump up the pressure, it really won't hurt your other tools, because it only sees the pressure it goes up to. In other words, it's only going to see that spike where that pin breaks. So even if it's set up to 8,000 pounds, the tool's not going to see 8,000 pounds.
You're going to see the tensile strength
Of the pin, exactly. Exactly, and that's how it works. So if you have to set your rigs up, you know, you're using two different guns, set it up for the higher one, and I really wouldn't worry about the older tools.
It's good to know, because sometimes when the power rigs go out, it goes God swap with another one. The pressure's not hard enough.
Ideally you want the pressure as low as you can maintain it, but in that situation, you know, it's better to have the right pressure than going out there on calls. As the rig sits, there's no pressure on it. The motor's not running until the tool is triggered. It trips the relays. It goes into pressure, pull, and that's just all by tripping the solenoid here in the directional valve. We're getting pressure out of there. It'll go, it's staying and remain in pressure until the trigger's released. Once the trigger's released, the motor remains running until a return pressure is achieved in this valve here, or switch. Once that's done, the unit shuts off. Then you go back to the cycle. If there's no oil in these units and you plug them in and trip them, they won't shut off because they won't build the pressure. So you got to unplug them and reset them. That's basically the function of the unit. Now we can go into setting the pressures. Gauges are pretty simple. You got two gauges and basically a T-valve. Generally have a button, but we'll get this started. And check return pressure. You're actually just going to shut the valve down. See, this gauge is starting to. We're about 88 on return. You don't. We're actually deadheading this machine, so you don't want to leave this on there forever. You want to get your pressure reading and get off. This is going to get our return pressure. We're out of there. The trigger off. This you got to creep up on it slowly to read it. Right about 21. Because as soon as you get to return pressure, it shuts the rig off. So in order to adjust the pressures, we have pull pressure. Okay, here's the pull pressure adjustment. There's a little lock ring on top, which isn't really locked too hard. Your pull pressure you can do while the rig is running. So you can go ahead and plug this in. You can actually, we just killed it, but let me give this a couple turns in and see what that does for us. We're going to back some more out of this.
That's the release pressure?
That's the, exactly. It's return pressure. Oops. We're going to leave it right there. We want to see at least a 2,000 split on return and pull. If you start getting within the less than the 1,000 range, the machine doesn't know what to do. It'll start flipping back and forth.
You mean like if this return was at 2,000 and the pulling pressure was at like 3?
You may have a problem. So a 2,000 split in the pressures is a good rule of thumb.
But right now we're way past that because it's set at 8,800, right?
Yeah, right now we're fine on that. Do you guys want to try checking the pressure yourself?
No, I'm okay with it.
You're confident you got that down?
Oh, yeah.
It's not that complicated. You just got to remember which one you're checking. You have to have it triggered to check the pull. You're actually deadheading it. And then to check your return, you're always backing the gauge off, cracking it open before you start the cycle. You put it in, pull it out, or hit the trigger and release it. You can do this with a tool too. Just stick the tool in there. Hit the trigger and release it, and then check your pressure for the return. On the units out there, I didn't realize you guys had any large units. That pressure is done on the block that's got the fittings coming right out the front of it. So there's a hex on both sides. As you're looking at the front of the machine going in, the right side is going to be a return pressure, the left side your pull pressure.
Oh, that's near the coil valve?
And I can show you that out there.
Right.
Same procedure here. You need a remote trigger, you can use a tool. I would use a tool out there because you got constant pressure. You don't want to just leave that in there. Same procedure for checking the pressure there.
Is it the same
So it should be about the same pressure.
same pressure?
You may end up with slightly higher pressure here because you don't have the volume to get the tool to work than you do there, rather than blowing something up on the tool.
Okay.
So you only use the pressure you're required to use. I mean, you use the safety margin on it. You go up, actually, you don't get right dead on the pressure it takes to break the pin. You go over that, but you don't want to go way over that. With the high pressure or the light tools, the power light tools as we call them, you have to go up to the upper ranges of the pressures to get them to break. It's actually harder on the rigs to pump up to that higher pressure than it is the lower pressure. But like I stated before, it only really sees what the pin pressure is.